Okay, good afternoon, students. Good morning or good evening, wherever you're watching from. This is Mr. Yomi, a mathematics teacher at this point international school. And today we'll be looking at a very important topic in mathematics. Actually, it's a foundational topic in mathematics, and the topic is indices. Actually, the word indices from the word index, which means to raise to power, So you can have something like this, and something like this. This is power, this is index. Okay, so we have the word index in singular, and then we have the word indices. Like you have your normal, just the way we have certain words that are having singular, and then you have them in plural. So this is the index, and then this is indices. And to navigate through this topic properly, it's important you know the rules that are associated with the topic. And so the topic has some rules. And so we have what we call the rules of indices. And we'll be looking at the rules, and then we go into some solving immediately. So we look at number one, multiplication rule. Here, what we have is that when we have a situation like this, you have a situation like this, the base are the same. Whenever the base are the same, you add the power. Whenever the base are the same, the power will be added. And so we call it multiplication rule. Maybe you may want to call it addition rule, since I'm adding them. Number two, we have what we call division rule. Now, before I look at this division rule, now I like to give an example here. For example, if you have something like this, and you have something, say, like this, obviously the power is the same. You have 2 raised to power 5. Why? Because you are adding 3 plus 2, and that gives you 5. Division rule. Here, you have something like this. The power is the same, and then you can see the base is the same rather, and then whenever you have a situation like this, you minus it. And so here we have A, and then here we have A. What happened to the power? You minus it. Number 3, what do we do here? Number 3, we have the power rule. And so, in this case, you have something like this. And let me proceed here. In a power rule, here, I'm calling it power rule because I want to prove to you that power can multiply power. And so, multiplying this by this will give you A multiplied by C. What does this imply? Just as we have here, let me do an example here for you. Here we have, say, minus, or let me put 1. And so we have 2, 3 minus 1, and 2 raised to power 2. That is the answer for this particular one. But for this now, how do we give an example in this? Let's give an example as this. We have 3 here as power, and then we have 2 outside. So this 3 is what you have here, the P here is what you have here, C is what you have here. So power multiply power, and so you have 3 raised to power 6. Please take note of this. This is the one multiplying this, and so you have 6 there. The next one is, you must know that whenever anything is raised to the power of 0, it is 1. When anything is raised to the power of 0, it is 1. When anything is raised to the power of 0, it is 1. So whether it is 100 that is raised to the power of 0, you have 1. Now, The number 4 is already established that anything that is raised to the power of 0, it gives you 1. Anything whatsoever, either alphabet or a number, it gives you 0. Now we go to the next one, which is very important, and that's when you have something like this. You have something like this, looking like fractional index, and then you have something like this. When you have an app like this, it's the same thing as this. You find some people, they want to transcribe this to this. You find them going to here. If you dare put to here, it's tautology. It's like somebody saying TX, or somebody saying 7 a.m. in the morning. That's tautology. There's no point. Once you have this and you put square root of a, that's the same thing. And what's the example we can look at here? Let's look at this example now. 16R. Looking at 16R, it gives you root 16, and then you have 4. That's what you have there. That's a classic example. Now we'll go to a more now looking at this now, the next one. So we have something like this. Now in this case, you look at it that number 5 and number 6 almost look alike, except that there's minus in this. Now, what do you do about this minus? Do not forget division rule. That whenever we have minus, that must be division. And whenever we have division, that must be what? Minus. Okay, so doing this now, for me to remove this minus, I'm going to do something like this, and then bring this down. I've eliminated it. I've eliminated the minus. And that's why I introduced 1 over. That's division minus. Now, then we have 1 over square root of a. And that's what you have there. How do we transcribe it? Let's use exactly what we did here. So we have a 2. This will give you 1 over 16 square root, or better still, let's say, let's simplify it this way. So we have 1 over 16, and then we have 1 over 16, and then we have 1 over 4. I'm sure that's very, very clear. I'm sure that's very, very clear. In case you're not clear, let me say it again. The difference between this and this is minus. The minus sign from division rule. You have this, and this is the same thing as this. And then I want to particularize what we have just done. So we have this. This is 1 over 16 raised to power r, and then the half there is the square root 16, and then square root of 16, you have 4. Now we go to the next, which is 7. And now this is very important. This is a situation where you have something like this. In this case now, how do you interpret this, please? It's important to know how to interpret it. To interpret this, we're going to have something like this. Now, we introduce our minus y to eliminate this. So we have a, we have 2, then we have 3. What's the next thing? 1 over, watch now, this is denominator. Denominator comes in here. And then you have your the value, the a here, and then y numerator comes here. Why is it so? Now you will discover all the one we've been doing before. Our numerator was unity, was 1. Unlike this, our numerator is not unity. What I mean is, our numerator is not 1 here, it's 2. So you can see here minus 2 over 3. Now, the reason I change this to this, of course, you know this is minus, and then you have this. Now, then you have 2, which is the numerator, and then denominator, you have your 3. Then the 3, which is like, so this is the same thing as when you have 2 over 3. This is the same thing as, watch now, 1 times 3, 2. This is like cube roots, and that's why we have the cube roots here. Why this is the power in numerator? That is why we have it here. That's why we have it here. This is so important for you to note. So now quickly, how do we explain this using this in terms of calculation? So let's quickly look at something. We have 64. we have 64, and then we have 2 over 3. So quickly this becomes 1 over 64, 2 over 3, that's 1 over square root of 64. 3 will be here, and 2 will be here. Now, how do we go about that? So we say, what's the cube root of 64? What that means is that when you think of number, we can multiply into 3 places that will give us 64. So we have 1 over 4. Do not forget, that's the cube root. And then we have the square right there. So if you have square, and then we have 1 over 16. So our answer now is 1 over 16. Till I come your way again, I remain your main Omorewa, your favorite math teacher at this Queen International School. Thank you. Bye. Okay, welcome to this Queen International School channel. We would like to continue from our previous class, still looking at laws of indices or rules of indices. Now, it's important you familiarize yourself with those laws and those rules. Number 8, I've considered 1 to 7. In case you are just coming, you can endeavor to follow up. Number 8, we were looking at something like this. In this case now, you have a numerator and a denominator as power, and then look at your base 2. So, what do? You simply do it this way. If you have been following, you will know that this is going to give us this. The cube root here, 1 over 3 multiplied by 2, that's why we have the cube root here. And then the power, which is 2, that's what we have there. Now we're going to be looking at the example how this can be applied in proper solving. Number 9, which is the last thing of what I'll be considering. The last thing, number 9, here you have A over B, all raised to power minus 2 over 3. A situation like this, do not forget our minus. We remove it by introducing 1. We have explained that earlier. So we have this over this. Our denominator will be here and our power remain here. This is what we're going to have. And this is quite simple and straightforward. Now, let's look at live example as we go now. So let's solve example. Some question now. So let's quickly go. On question number 1. Simplify the following. Question 2, evaluate. So we have all of this. We have all of this to take care of. So we quickly solve number one. Number one, we have three. We have to bring in this together and bring this together. Okay, so we have 3, 2, and then 3 is the power 4, and then we have this 3 is the power 2. So from the law of indices, multiplication, we are adding the power. So we have this, and then we are having this. So this will give us 2 minus 4, and this will give us 5. So therefore, we have minus 2 for here, and we have 2 raised to the power 5 here. You can also say that 2 raised to the power 5 or 3 raised to the power 2 for here. Okay, so we can also express this in this regard and say 2 raised to the power 5 divided by 3 raised to the power 2. And this is the same thing as 32 over 9 as our final answer. So till like come your way again by 2. From our division law, we have 2 raised to the power 3 divided by 2 raised to the power 4. Okay, now from our law, we know that this is the same thing as 2 raised to the power 2. You can say now minus the bracket this. Automatically we have this now. Minus times minus, that's plus. And then we have 4. So this is 2 raised to the power 7. Okay, 2 raised to the power 7. That's 2 raised to the power 5, 32, 2 raised to the power 6, 64, and 2 raised to the power 7, 128. So the answer is 128. Okay, so we want to deal with this. Dealing with this is not an issue. So the answer to this obviously is 5. Just cube root of 125. So I'm not going to solve this. That the answer to this, how do you do this now? The cube root, the answer to this is 4. It is solved already, but you can try it and solve. And then, in case you're not clear with what I just said, I said that is 5 if you solve. This is 4 if you solve. And then you don't get what I've just told you now. Drop it in the comment section. It will be explained. Let me move to this quickly. So you have 27 divided by 8. Now, from our law, we know that this is the same thing as 1 over 27 divided by 8. From what we have explained previously. And this is the same thing as this. 27 divided by 8, our 3 here denominator, and then our power here. So from what we have here, we know that number we can multiply into 3 places, the cube root, into 3 places. So we say, what number can I multiply into 3 places to give me 27? 3 times 3 times 3. Okay, thank you. That is 3. And then I ask myself for 8. What number can I multiply into 3 places to give me 8? Obviously it's 2. So I have that. And this will give me 2. So 1 over 3 raised to the power 2, that's 9. 2 raised to the power 2, that's 4. And so we invert it, that's 4 over 9. That's the answer to the question. Okay, so we're looking at E. You wonder I jumped D. D is quite simple now. This is 2. This is 3. 2 plus 3. No, sorry, this is 2. This is 5. 2 plus 5. What do you have? That's 7. Raised to the power 2. That's 49. Okay, so I'm not doing that now. So let's go to E. Our E says Okay, so let's treat this. You can leave here, leave this question and treat this. So we have 2, we have 64, and then 1 over 64. I guess you know why I did that now, for the minus. So we have this 64, 125, 3, and then we have 2 here. Thank you. So this will give us what? 1. Number I can multiply to 4 places to give me 64. That's 4. 4 times 4 times 4. Number I can multiply to 3 places to give me 125. That's 5. And then the square, I'll put it there. So I'm going to have 1 over 16, that's 4 raised to power 2, and then 5 raised to power 2, that's 25. So this will give me 16, 25 over 16. Remember, I have 2 divided by 25 over 16, which is 2 multiplied by 16 over 25. And that is 32 over 25, which is 1 over 7 over 25. Okay, we're solving our last question under this indices, our last question to be solved. So we're looking at a question now. 3 raised to power n minus 1 multiplied by 27. N plus 1 over 81 raised to power n. This is pretty simple. Just express it in terms of 3. So you have this now. Now leave that. Come to this first. You have raised to power 3 n plus 1. Close it. This is the same thing as 3 raised to power 4. Then you have n there. Come down and ask yourself, what can you do there? So you have 3 raised to power n. So we have this. And then from here we have n, 3n plus 3 over 3 raised to power 4. And so I have this. Now look at this now. I will split this 2. I will have this. And then I will split it from the law of indices, law of multiplication. Then I will have this. So from here, I will ask myself what is common. What is common? So you can see what's happening here. This plus this. So I will have 3 raised to power n times 3 raised to power n times minus 1 times 3 raised to power 3 over 3 raised to power 4n. This is the same thing as 3 raised to power 4n, 3 raised to power minus 1, and 3 raised to power 3 over 3 raised to power 4n. Cancel, cancel. I am left with 3 raised to power minus 1 times 3 raised to power 3. Now the same thing, that is the same thing as 3 raised to power 3 over 3. That's it. Which is 27 over 3. And then you have, what do you have there? 9. So our answer is 9. I bring the teaching on indices to a close. Till I come your way to consider in teacher equation, I remain your me or moreover. I must